Okay, update number 2. Not sure if I put this in the last one or not, but we have our modified wheel made up. So as our magnet holes now line up. Also got our test rig finished here. All our core laminates are glued in position with super glue. Super glue all over my fingers. So I have to just set you up here on the bench with my mini tripod, plexi spider leg looking thing. Try and get the level. Okay. Excuse me. So glued all the laminates in. Just have to run a file along the inside, get rid of all the little bits that are sticking out, because when you're using super glue, once they touch, it's pretty much all stuck and I can't move it. So I tried to keep it as even as possible. Not too bad, but a couple little fingers sticking out there. This here I printed up, and I printed it that way and had all support in here and in between here, and it took me 20 minutes to get it out. I've still got to play with the adjustments a bit on the slicer, because it's actually sticking the support to the product a bit too much, as you can probably see there. That's the layer of support in there I'm yet to peel off. So the idea with this is, which of course sits in there, pin goes through here, and we have a little knobby bit on here we loop our little wire onto that runs around this radius and to the scales. So we're actually measuring static torques, but we're not going to get into that again. So this is the first of the 1 + 1 = 3 tests, which we don't want in this case. So we can afford to go 150% more with 2 magnets than we have with 1 magnet as far as our pull force tests go. So first we put 1 magnet in here, and we just let it pull into where it's sitting steady, and then we tension it up just until it's starting to pull back into the core. And we also have here, finished printing up, scale holder, and we put a bit a long threaded bolt in here through this hole with a nut in there. So when I do 1 rotation, it's going to pull the scales back 1 mil. And of course our scales will be sitting over here somewhere. I'll make up a frame for it with the cable around this half wheel here and hooked onto that little knob. So I can then carry out the test with 1 magnet and write down each mil of pull force it has back towards the core till such time as we get close to 0, or we get to 0. And then I can take all those values and graph them out. Then what we do is we put another magnet in this side with opposing fields facing each other, and then we carry out that same test again. So we can afford to have 150% more with 2 magnets than we've got with 1 magnet, and the motor will still work. Once we get up to our 200% more, which is 1 + 1 = 3, we start to run out of luck pretty fast. So that's what this rig is for, and that's our next test. So this centre is a lot wider, and I want to carry out this test just so I know if I have to add more mass or less. So once that one's done, we do exactly the same here, same test, but with our little thin 2 mil laminates on the inside. So we have 2 mil there, 1 mil spacer, another 2 mil, and that will give us our 5mm. And here I have a 6mm gap between the magnets, so we want to keep that gap as close as possible, but we also want enough steel there that the poles of the magnet still loop. So I'm hoping that because the poles are now looping, we're not going to get that 1 + 1 = 3 effect. In the normal situation, like in our torque plate motor thread, we had the 2 north poles facing like this, and that would give us 3 times the pull back towards the core. That's because these fields here weren't looped. So I'm hoping by looping the fields, of course they will be separate cores for each magnet, not a full core like this, but doing this test allows me to see the difference between the two. So I'm hoping that the 2 north fields are going to loop quite strongly, because thin laminate here and thick there means the south field is going to be right over to one side on the bottom of the loop, which should pull the north in nice and strong. But I can't carry out this test until I get my shears, because there's no way in hell I'm cutting 120 of these like that with the snips, because it was very hard to get accurate with the hand snips. So once I get my bench shears, I'll be able to make up a die with the new milling machine, and clamp each one of the laminates in there and carve off the bit we need. Alright, so that was today's progress. We printed up the correct wheel, printed up the new former and the test wheel, glued all the laminates in. That we'd already done. Printed this up for the scales so we can have movable scales, and at the moment we're doing a very big print. So as you can see, that's a very large part. That is 1/2 of our stator. This print, some 5 hours long, so we've done 4 hours 58 minutes and we've got 51 minutes to go, so nearly 6 hours. Just out of curiosity, plugged it into the A8 slicer, and it was going to be a 17-hour print. This machine here done it. It's going to do it in 6. So this has actually cut my time down by 2/3 having this machine, and we're actually moving along a lot faster than I thought I would. So we're going to be well under our 4 months at this rate. So that's tonight's update. We're moving along quite nicely, and I've got this printer dialed in pretty good now. I've got a few little cobwebs there, but they just wipe out with your finger, and it's expected when you've got big gaps like that, because I didn't want to go light on the filament. So we've nearly used half a kilo in this print alone. And I'm making them big and solid like this because I actually want to try and get the motor to work, or a plastic motor to work. See if we can stop the twisting, because like I said, we only got 1/2 mil gap between the magnets and the laminates, and they really want to pull towards the laminate. So hopefully with this new printer and putting lots of infill and that in there, we can have it sturdy enough that plastic motor might actually work. Alright guys, have a great night.